Study guide for test 2. Find the value for the variable that makes the equation true. The square root of 5 times the square root of 5 is equal to y. So y is going to be multiplying these two 5's together to make the square root of 25. And the square root of 25 is 5. So y is 5. Problem 2, we have 8 over 7 raised to the negative 1. And you can see on the left side, n over m doesn't have that set of parentheses with a negative 1. So to try to recreate the fraction with no parentheses and a negative 1, I need to use the negative exponent property by turning this into a positive 1. And all I got to do is flip the fraction, and now that negative 1 is a positive 1. So if I do 7 to the first power, that's 7. 8 to the first power, that's 8. Now it matches up to the fraction on the left. So the n is going to be 7, and the m is going to be 8. Problem 3, same directions as before. So here we have a single radical, and here we have two rational exponents with a time sign, which means I'm going to multiply this together, and when I do that, the fractions get added, those exponents get added. So I'll have 5 over 10 plus 3 over 10 is going to give me 7 with 8 over 10. Now looking at this radical, I can see there's an index of a 5, but currently with the way my fraction's set up, I have a 10 where the index location is. That means I need to reduce this fraction by 2, so I have 4 over 5. So now when I write it as a radical, the 7 goes on the inside, 4 is the exponent, and 5 is the index. So therefore k would need to be 4. Problem 4, you can see that we have 3x to the fourth raised to the n. And so anytime you have an exponent raised to an exponent, that's multiplication. So 3 times some number is going to get me the 12. You would imagine 3 times 4 is 12. But you'll notice that the 3x to the fourth being multiplied by 3 does not make that move to the bottom. So I have to make that a negative 3 so that x ends up on the bottom of this fraction. Therefore, the n is going to be negative 3. Just like we look here, y to the m, and then we can notice that the y is now on top of the fraction. That means that the m would need to be a negative exponent, and therefore negative 5. Y to the negative fifth, to make that positive, we move it to the top. Now it's y to the positive 5. It says write the radical as a rational exponent, simplify if possible. I would recommend that you simplify first, then write your answers as rational exponents. It will make your life easier when doing these problems, and it will work every time. So I'm going to break down 729. I know that 3 times 243 would be 729, and then 3 times 81 is the 243, and 9 times 9 is 81, and 9 is 3 and 3, 3 and 3. And since the index is a 3, I'm looking for 3 of the same number. I have 2 different sets of 3 of the same number. So I'm going to have 3 times 3 outside of the radical. And then I have 18 x's. 1, 2, 3, 6, 9, 12, 15, and 18. 1 circle, 2 circle, 3, 4, 5, and 6. So I'll have x to the 6. I'm going to do the same thing for the y's. 1, 2, 3, 6, 9, and 12. 1, 2, 3, 4. Y to the fourth. Now you'll notice in this problem that I didn't have any y's left over, or any x's, or even any numbers left over. Everything got circled. So the radical is now gone. So my answer is simply going to be 9x to the 6th, y to the 4th. If we look at problem 6 and go with the same approach, This time, you'll notice that we do not have a number in the index. So that means it's really a 2. So I'm going to break down 196 into 2 times 96. And then I'll break that one down into 2 times 48. And this will be 6 times 8. And then 6 is 2 times 3. And 8 is 2 times 4. And 4 is 2 times 2. Once again, since the index is a 2, I'm looking for 2 of the same number. I have 2 of the same number here, 2 of the same number here, and 2 of the same number there. I have 3 circles for 2's. So outside the radical, I'm going to have 2 times 2 times 2. 1 for each of the 2's that I circled. However, I will have a 3 left inside the radical because I couldn't circle that with anything. Then I'm going to go ahead and deal with my variables. I have 6 x's. That's 4 and 6. 1 circle, 2 circle, 3 circle. So I'll have x to the third. I'll then do 5 y's. 1, 2, 3, 4, 5. 1, 2. 2 circles. Y to the second. Now, I do have a y left over, so I have to write that inside the radical. So I'm going to start to clean this up a little bit. I have 2 times 2 times 2, that's 8. X to the third, y to the second, with the radical 3y. But it told me to write my answers as rational exponents, which means I need to make sure that I don't have any radicals in my answer. So I'll have 8 x to the third, y to the second, and then I will rewrite this radical as parentheses 3y, once again, exponent over index 1 over 2. And you might say, where did the 1 come from? Well, keep in mind that I can put parentheses around this and put a 1 here. So exponent is a 1 over the index of 2. And this would be my answer written in rational exponent form. All right, we're going to rewrite this as rational exponents and simplify if possible. So to do that, I actually suggest that we simplify first, and then we rewrite it as rational exponents. It makes the problem a lot easier. So 250 divided by 2 is going to be 125. And then I'm going to go ahead and I'm going to divide my b's, which means I subtract the exponents. So -5 minus 3 is going to give me b to the -8. I'm going to do the same thing for the y. 17 minus 2 is going to give me y to the 15th. I'm going to go ahead and simplify my 125 down to 5 times 25, and then 25 as 5 times 5. And then I'm going to circle 3 of the same number because my index is a 3. That's going to have me take my 5 out of the radical, and then I'm going to write what I have left over, which is going to be the cube root of b to the -8 and y to the 15th. This is where I'm going to rewrite it as a rational exponent because I just wanted to make my life easier, and I think it's easier to do it this way. So now I'm going to have 5. I'll have b, exponent goes on top, index goes on the bottom, exponent goes on top, index goes on the bottom. I'm going to go ahead and clean up my problem. So I have a 5. Now, I don't like negative exponents, so I'm going to shift that to the bottom, where I'll have b to the positive 8 over 3. And then 15 divided by 3 is really 5. And so now I have written it in rational exponent form, and I've simplified it at the same time. Number 8. I'm going to start off with doing 80 divided by 5, which is 16. 15 minus 3 for the x's, which is going to give me x to the 12th. -1 minus 2 is going to give me y to the -3. I'm going to go ahead and simplify 16. That's 4 times 4, 2 and 2, 2 and 2. And once again, the index is a 4, so I want to circle 4 of the same thing. So I'll have a 2 outside the radical. Don't forget your index. X to the 12th, y to the -3. Once again, now I'm going to write them as rational exponents. So I'll have 2x, exponent goes on top, index on the bottom. Exponent goes on top, index goes on the bottom. Now we write our final answer. I'll have 2, 12 divided by 4 is 3, so 2x to the third over, since the negative 3 over 4 has a negative exponent, I will make it positive by moving it to the bottom. And there we go. Number 9, write the expression in two different ways so that one expression is a radical form and one is in a rational form. So if we rewrite the problem, 4x to the third times the radical cube root x squared, I can't just write this. This is partially in a radical form. This is not, I suppose. But if we want this whole thing in a radical form or a whole thing as a rational exponent form, I think the best thing to do is to write it as a single radical and a single rational exponent. So to do that, we're going to rewrite this so we convert the radical into a rational exponent. Once again, exponent goes on top, index goes on the bottom. Now I have a base of x and a base of x on these exponents, which means since they are the same base, the x and x, I can add these two values, 3 and 2/3. So I'm going to go off to the side for a moment and I'm going to add them together. They do not have like denominators, so I need to give them like denominators. So I'll have 9 over 3 plus 2 over 3, and I add them together. That's going to give me an 11 over 3. So now I have 4x to the 11 over 3. I have now written it a rational exponent form. And now I can take that and I can also write it as a radical. Now keep in mind that this fractional exponent is only connected to the x, not the 4. So when I write it as a radical, that 4 will be outside the radical. Exponent's on top. Index is on the bottom of that fraction. So we will have 4 cube root x to the 11th. And that's our radical form. Another problem where we have an expression that we want to write in radical form and one in rational exponent form. And once again, I would suggest just combining the two, do the multiplication and then write it in both those forms. So we currently have 6x to the 2 over 3 times 3 fourth root x to the first. So I'm going to rewrite the radical as a rational exponent. Exponent goes on top, index goes on the bottom. Once again, the exponent is tied to the x itself, not to the numbers 6 and 3. It's tied to the x. Okay? Therefore, with the times sign here, I can add the two fractions together because their bases are the same. So I'm going to go off to the side and I'm going to do that math. I have 2 over 3 plus 1 over 4. I want like denominators, so I'm going to times this one by 4, top and bottom, and then this one by 3, top and bottom. I'm multiplying by each other's denominators, which is going to give me 8 over 12 plus 3 over 12. So 8 plus 3 is 11 over 12. So now I have x to the 11 over 12. And then I'm going to take the 3 and the 6. They're going to get times together to get 18. And now I'm in rational exponent form. And then I can take that single answer that I have here, and I can write it as a radical. Once again, that 11 over 12 is connected to the x, not the 18. So the 18 is going to be in front of the radical with an index of 12 and an exponent of 11. And now you're in radical form. Problem 11, simplify the radical. So we're going to break it down. We got an 81, And if we're going to break it down, we should know what our index is. Currently, you don't see one written because it's really the invisible 2. So I'm looking to circle 2 of the same number. So 81 is 9 times 9. 9 is 3 and 3. 9 is 3 and 3. So now I have a pair of 3's and another pair of 3's. So I have 2 sets of 3's. So I'm going to write a 3 outside. This 3 represents the first circle. This 3 right here represents the second circle. And then I'm going to leave a little space for probably some variables. And I have my radical. I have 11 x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So once again, index is 2, 2 of the same thing, 1, 2, 3, 4, 5. So I'll have x to the 5th outside the radical. I had an x left over, so it'll go inside the radical. Time to clean this up. 3 times 3, that's 9. You can see that my index is the 2, and I have an odd exponent, which means I should put absolute value signs around the x to the 5th. And there's my answer. Okay, now our index is a 3. So I'm looking for 3 of the same number. So taking 108, that is 2 times 54. 54 is 9 times 6. 9 is 3 and 3. 6 is 3 and 2. Once again, we're looking for 3 of the same number, and we only have one set that is 3 of the same number, and that's 3 3's. So I'm going to write a 3 outside the radical. I write my radical sign, don't forget your index, and I have a 2 and a 2 that didn't get circled, so it's going to go inside the radical. I now have 9 x's. 1, 2, 3, 6, and 9. 3 of the same thing. I have 3 of those circles, so I'll have x to the 3rd. I'm going to do the same thing with the y's. I have 1, 2, 3, 4, 5, 6, 9, 10, and 11. 1 circle, 2 circle, 3 circle. Y to the 3rd. But we have 2 y's left over, so it's going to go inside. Time to clean up the problem. 3 x to the 3rd, y to the 3rd. Don't forget your index, which is a 3. 2 times 2 is 4, y squared. Now this time, I'm not doing any absolute value signs, and that's because I have an index that is a 3. If your index is odd, no absolute value signs. Number 13. This time we have an index of 4. So we are going to simplify and then find 4 of the same number. So 2 times 48 is 96. So this is 6 times 8. This is 2 times 3. 2 times 4. 2 times 2. 4 of the same number. So 2. There we go. 4 of the same number. So I'll write a 2 outside the radical. Don't forget to write your index. I had a 3 and a 2 that did not get circled. So that's going to go inside the radical. And I have 12 x's. So 1 circle, 2 circle, 3 circles. X to the 3rd. Going to do the same thing with the y's. 1, 2, 3, 4, 8, and 9. 1 circle, 2 circle, y to the 2nd. 1 y left over. All right, just going to clean this up. We got 2. Now our index is even, so if we have an odd exponent, it should go in absolute value signs. Index is a 4. 3 times 2 is 6. Then we have the y, and there's our answer. Okay, perform the appropriate operation and simplify if possible. So we're essentially adding and subtracting these radicals, so we have to look very carefully at them because they all look kind of the same. To add and subtract radicals, we care about having the same radical, which you'll notice we do. They're all square root 5x's. every single one of them. The 5x, you can't make 5 any smaller, and you don't have enough x's to do any circles, so you can't simplify those. So now it becomes, do we add them all together? Do we subtract them all together? Is there something that's a little different about them? And if you look carefully outside of the radical sign, you'll notice one of them has x squared. You have an 8x squared and a minus 2x squared. And then here, you got yourself an 11x and a minus 6x. They can only combine like terms. So even though the radicals have to be the same, so do the coefficients in front. If this is an x squared, you can only match it with an x squared. So if I have 8x squared minus 2x squared, that's going to give me 6x squared with a square root of 5x. Then the 11x and the minus 6x, they're both just a single x, so we can put those together. 11 take away 6 is 5x, square root 5. And that's as good as it gets. All right, perform the appropriate operation and simplify if possible. So this time we see that we have square root 7s and cube root 7s. A square root and a cube root are two different things. They're different values, so they cannot be combined. So we have to go with matching radicals. So the square root ones will get combined and the cube root ones will get combined. So 4 plus 9 is 13 square root 7. 12 take away 2 is 10 cube root 7. Don't forget to write your indexes. If you miss those, you will lose points. Don't forget to write them. Okay, same directions as before. So this time we're doing multiplication because we have two parentheses right next to each other. So when it comes to multiplying, we're going to multiply the outsides and multiply the insides. So outside we have 2 times 6, that's 12. Square root 15 times 30 is 450. And then when we multiply, we add exponents. So we're going to get x to the 8th. Now we're going to go ahead and we're going to simplify, because it does state that we need to simplify if possible. 450, breaking it down to 15 and 30, which you might notice those are the two numbers I multiplied together to begin with. We're going to have 3 times 5 for the 15, 3 times 10 for the 30, and then 2 times 5 for the 10. Since it's a square root, once again, invisible 2, we're going to circle 2 of the same number. So we have 2 3s here, and we have 2 5s. So outside the radical, I've got the 12 that I originally had. Then I'm taking a 5 out and a 3 out, because that's what I was able to circle. Inside the radical, I have a 2 that's going to be left inside, because that 2 had nothing to circle with. Then I'm going to deal with the x's. I have 8 of them. And once again, index is 2, so 2 of the same thing. I'm going to have 4 circles for x's, so I have x to the 4th. And now I'm just going to go ahead and do 12 times 5 times 3 gets me 180 x to the 4th square root 2. I don't have any odd exponents, so I don't have to worry about absolute value signs for this problem. 17. Once again, multiply the outside numbers, multiply the inside numbers. Negative 4 times negative 3 is positive 12 square root. 8 times 12 is 96. And when we multiply, we add exponents, so 2 plus 9 is 11. We're going to break down the 96. So we're going to have 2 times 48, 6 times 8, 3 times 2, 2 times 4, 2 times 2. Once again, we are dealing with a square root. It's the invisible 2, so we are going to be looking for 2 of the same number, 2 of the same number, 2 of the same number, and that's all I can do. So I'm going to go ahead. I have a 12 that's already out there. Now I'm going to bring a 2 out, then another 2 out, and then inside the radical, I have a 2 and a 3 because they didn't get circled, so they stay inside. I have 11 x's. 1, 2, that's 4, 6, 8, 10, 11. 1, 2, 3, 4, 5. So I'll have x to the 5th with an x still on the inside because it couldn't be circled. So 12 times 2 times 2 is 48. And this time we have an even index with an odd exponent, so it gets absolute value signs. 2 times 3 is 6, x. And we've got our answer. All right, so this time we're going to divide and then simplify. So 144 divided by 3 is 48. Don't forget your index. 27 minus 3 is x to the 24th. We're going to go ahead and simplify 48. 6 times 8, 4 times 2, 2 times 2, 2 times 3. All right, we are looking for 4 of the same number. We have 1, 2, 3, 4 2's. So I'll write a 2 outside the radical. Don't forget to write your index. We have a 3 that didn't get circled, goes inside. And then I have x to the 24. That's a lot of x's to have to write out and do circles. And so there is a shortcut. And I'm going to write out all the x's, and then I'm going to explain to you how to do it in your head, and so you can see a visual. So 1, 2, 3, 4, then this would be 8, and this would be 12, 16, 20, 24. So that's 1, 2, 3, 4, 5, 6. 6 circles, x to the 6. But no one wants to write all this out. That's a lot of work. There is a faster way. Take your exponent, the 24, divide it by the index 4. That gives me 6. That's the exponent. That's how many groups that would be created by grouping 24 x's into groups of 4. Basic division. So I now have my answer. 2x to the 6, 4th root 3. Nice and pretty. Number 19. 66 divided by an 11 is going to give me 6. 13 take away 6 is going to give me x to the 7th. I try to break down 6, I get 2 and 3. There's nothing to circle with an index of a 2. So inside the radical, I'll just have 2 times 3, or you could just write 6. But now I have 7. I could write out 7 x's, or I can try that new shortcut I told you about. 7 divided by 2. Well, that's not a whole number, and I need whole numbers. No decimals. So how do I do this with the shortcut? Instead of asking the question 7 divided by 2, instead ask yourself 2 times what number gets me close to 7 but not go over. 2 times 3 is 6. That means it's going to be x to the 3rd, because 2 times 3 is 6, but if you only get up to 6, you need one more to get to 7. Let me show you visually what just happened there. So we have our 7 x's. 2 times 3 is 6. 1, 2, 3. That 3 is representing those 3 circles. But you can know if you get as high as 6, there's a difference of 1 from 6 to 7, which means there's that extra x that you needed. If that helps, use it. If not, you can always write out all the x's you need and do the circles. So just kind of clean this up. We have x to the 3rd. The index is the invisible 2, so it's even. And our exponent is odd, so it should have absolute value signs. 6x inside the square root. There you go. Okay, so this problem is asking us to subtract these radicals and simplify. Well, if we look underneath these radicals, they're all square roots, so that's pretty good, but none of the numbers inside are the same, which means I can't just subtract these. I need to simplify first and then see if anything will subtract. So let's go ahead and start simplifying. First radical has a 2. I can't make that any smaller, so I'll need to see if I can make these x's smaller, which it can. I'm going to go ahead and write out 8 x's, 1 circle, 2 circle, 3, 4. So I have 7x to the 4th square root 2. Then I have And 8, I can make that smaller. 4 times 2, 2 times 2. The index is a 2, so I need to circle 2 of the same number. So I have minus, I have an x out there, and I'm now going to write a 2 because of the circle. Inside the radical, I have a 2 left over. But I have some x's that I can simplify, and I have 6 of them. 1 circle, 2 circle, 3 circle. So this is x to the third, but I already have an x out there, so that's a total of 4. 1, 2, 3, 4. 4x, x to the fourth. Then our last one, we have got ourselves a 45. So that would be 9 times 5, and 9 is 3 times 3. So I have one circle, so 3 goes on the outside. I have 2 x's, so I have an x that goes outside, and I have a 5 that couldn't be circled, stays on the inside. Now I'm looking at these, and I notice that they're all square roots. 2 of them has a square root of 2, and if you look carefully, they also have x to the fourth on the outside, which means I can combine those two. 7 take away 2 is 5, x to the fourth, square root of 2, minus 3x, square root 5. But we're not done, because we have even indexes. And if you have an even index with an odd exponent, which you have right here, because that exponent is really a 1, you need your absolute value signs. Don't forget them. Okay, problem 21. Perform the operations and simplify the expression. Write your answers using rational exponents. Okay, so we can go ahead and rewrite this as rational exponents. So we have 2x to the 1/2. Once again, invisible 1 for the exponent, invisible 2 for the index. That's going to be times 9x, exponent goes on top. Once again, invisible 2 for the exponent, minus 4, and we have x. Once again, invisible 1 for the exponent, 2 for the index, 1/2, all over 2x squared. Now we need to go ahead and use distributive property. So we can multiply like so. Well, when that happens, it basically looks like this. We have minus, and these two are going to get multiplied together. And so when we multiply, we do add the exponents. So 1/2 plus 3 over 2, I'm going to go off to the side, 1/2 plus 3 over 2 is 4 over 2, which is a 2. So when I multiply together, I'm going to get an exponent of 2. So 2 times 9 is 18x to the second. I'm going to go ahead and do the same thing on the other side. I'm going to multiply together, so I'm going to have 2 times 4, that's 8. But then I'm going to take the fractions, 1/2 plus 1/2. That's 2 over 2, which gets me a 1. So I just have an x over 2x squared. Now, it wants us to simplify the expression, and this is not simplified. And that's because these three values have things in common. So 18, 8, and a 2 have a 2 in common. So I can reduce by 2. So I'm going to divide each number by 2. So 18 divided by 2 is 9, x squared. 8 divided by 2 is 4x. 2 divided by 2 is 1 with an x squared. But I'm still not done. All three of them share at least one x. So x squared means that there's actually 2 x's here. There's 2 x's here. So I can actually reduce each of these by a single x. So I can divide away an x in each location, giving me 9x minus 4 over x. And now it's simplified. Last problem of the study guide. So this is the review problem from the last test. So this is where you can earn quite a few points back on the test 1 if you do well on this question. So this says factor this polynomial completely given this polynomial is one of the factors. So this is where on the last test you probably did synthetic division and then you used your box to find the other factors. This time, since they've not given you a linear factor, they're giving you a quadratic factor, you can't use synthetic division. Instead, you have to use long division to do this. So we're going to set up our long division problem. So we have x squared plus 10x plus 16, and then we're going to have our x to the 4th plus 8x to the 3rd minus 19x squared minus 182x minus 240. All right, so going with the process of long division, we ask ourselves, what times x squared would get us x to the 4th? X squared. Once again, line up your exponents. An x squared and an x squared should line up. So x squared times x squared is x to the 4th. X squared times 10x is 10x to the 3rd. X squared times 16, 16x squared. We go ahead and we draw our line and we switch our signs. So the first two are now going to cancel out. 8 take away 2, 10 take away 10. 8 take away 10 is negative 2, x to the 3rd. Negative 19 minus 16 is negative 35x squared. I'm going to drop down my next term. Going to go through the process again. Got to figure out what times x squared is going to give me negative 2x to the 3rd. Negative 2x. So negative 2x times x squared is negative 2x to the 3rd. Negative 2x times 10 is negative 20x squared. Negative 2x times 16 is negative 32x. Draw your line. Now switch your signs. The first two are now going to cancel out. We're going to have negative 15x squared negative 150x. I'm going to drop down the negative 240. All right, so now we're going to do it again. What times x squared is going to give us negative 15x squared will be negative 15. So negative 15 times x squared is negative 15x squared. Negative 15 times 10 is going to give us negative 150x. And negative 15 times 16 is negative 240 plus, plus, plus. Switching all of our signs. The first two cancel, these cancel, these cancel. So we have a remainder of 0. So now we have x squared minus 2x minus 15. So now that we have the x squared, we're going to factor that using the box. So we have x squared here. We've got our negative 15 here, negative 2x here. X squared times negative 15 is negative 15x squared. And so we need to figure out two numbers that multiply to be negative 15x squared, but those same two numbers will combine to be negative 2x. So negative 5x times 3x is negative 15x squared. Negative 5x plus 3x is negative 2x. So x times x is x squared, x times 3 is 3x, x times negative 5 is negative 5x. So our factors for this problem are x squared plus 10x plus 16, the one that they gave you, and x minus 5, x plus 3. These are the factors they're looking for. Could we factor even more? Yes, we could break down the x squared plus 10x plus 16, but the goal of this problem was to see if can you still do long division and can you still factor. I wouldn't call this completely factored, but this is what we're looking for.